SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. Section. This section, which is our last section of chapter 10, I apologize, that was wrong, um, is the trigonometry section dealing with the trig ratios. Those trig ratios are called sine, cosine, and tangent, and you may have seen them on a calculator as the SIN, the COS, and the TAN. So we're going to use sine, cosine, and tangent ratios to determine side lengths and angle measures in right triangles. And we're going to use this thing SOHCAHTOA. It's going to help us remember how to use sine, cosine, and tangent. So, getting into this, these are the three trig ratios. One thing you got to know before we get into the trig ratios is just a little bit about right triangles. When we're dealing with these trig ratios, just like with the Pythagorean theorem, we have to deal with a right triangle. And remember, the hypotenuse is always the largest side. It's the one that's opposite of the right angle. So when we're using sine, cosine, and tangent, what's going to go in the sine, the cosine, or the tangent has to be an angle. It's going to either be used we're going to plug in an angle, or we're going to use find that angle measure. And it cannot be the right angle. We can use either of the other two angles, but we can't use the right angle. So that's important to know. So what is sine of an angle? Let's say if our angle x there. To find sine of an angle, use the so part of so, toa. That's why I was saying SOHCAHTOA. Okay? The so part is sine is equal to, so sine is equal to opposite over hypotenuse, meaning if you take the sine of an angle, that's going to be equal to the opposite side of that, the opposite side from that angle, over the hypotenuse, which would be the only one that's the hypotenuse. The cosine, or the c, would be cosine is adjacent over hypotenuse. H is still hypotenuse. A is the adjacent side. It's the other side that's touching this angle that's not the hypotenuse. And our tangent ratio is the TOA. Tangent is equal to opposite over adjacent. So tangent of this angle would be the opposite side over the adjacent side. Opposite over adjacent. All right? And we can use these ratios to find a missing angle measure or to find a missing side length. So here's how it works. Well, actually, let's first write the ratios here. Let's make sure we know how to do them. So write the ratios for sine of d. We're dealing with angle d here. Sine of d, cosine of d, and tangent of d. All right, sine is the so. So would be opposite over hypotenuse. So the opposite one would be 8. And the hypotenuse would be 17. So it's 8 over 17. Cosine of d would be adjacent. C would be, cosine is adjacent over hypotenuse, so it's 15 over 17. The tangent ratio would be TOA, opposite over adjacent, so that would be 8 over 15. All right. Let's do it for number 2 here. Add a little bit to it. Sine of E, cosine of E, and tangent of E. All right, E. Opposite would be right there, hypotenuse would be right there, and this would be adjacent. So sine is so it would be opposite over hypotenuse. So it would be 5 over the hypotenuse of 10, or 1/2. Cosine is adjacent over hypotenuse. So it's 5 square roots of 3 over 10, which would reduce, as we worked on past previous sections, we reduce the 5 over 10, which would be just 1 square root of 3 over 2. And then finally, tangent, TOA, opposite, or 5 over 5 square roots of 3. Remember, we got to get rid of that square root of 3 on the bottom. So to get rid of the square root of 3 on the bottom, we can multiply both the top and the bottom by the square root of 3. And we're left with 5 square roots of 3 over 5 square root of 3 times square root of 3 would be 3. 5 times 3. These are just going to cancel out. So we're just left with the square root of 3 over 3. That would be our tangent ratio. Alright, so that's writing the ratios. Now we're going to use the ratios to find a missing side or a missing angle. Let's start with missing sides. So for a graphing calculator or a regular calculator, most calculators have the sine, cosine, and tangent functions on them. So we're going to have to use the calculator to find our things. But we have to first set it up. So for number 3, it says find the value of x. Okay, we have this angle. So opposite would be here, hypotenuse would be here, adjacent would be here. We have the adjacent and the hypotenuse. So we're going to have to use cosine to find x. So we're going to say cosine of 34 is equal to cosine, adjacent, so that'd be x, over hypotenuse, which is 8. So then to solve for x, we multiply both sides by 8. So x is going to be equal to whatever 8 times the cosine of 34 is. So I'm going to plug that in here. I'm going to do cosine of 34. There's the cosine of 34. And then I'm going to multiply that by 8. And I get 6. So what is it? 6.6, we'll say. We'll round it. 6.6 is our x. And if you look at it, it does make sense. The longest side is 8, so the second longest side would have to be slightly smaller than that, and it is 6.6. So that's how you use the trig ratios and use it in the calculator. So let's try number 4. Actually, if you want to pause it for any of these, you can pause it and try them on your own and then check. So number 4, we have this angle. We have the opposite, and we have the hypotenuse. So that's going to be which is sine. So sine of the angle 22 is equal to opposite, so that's our x, over hypotenuse, which is 14. So again, for this one, we are going to multiply both sides by 14. And then we'll get x by itself. So x is going to be equal to the sine of 22 times 14. So clear it here. We have to do 22 and then click sine. And then multiply by 14. I got 5.2. And judging by the picture, I think that's a good estimate as well. So 5.2 looks good for x. So again, we are using these trig ratios to solve just for a missing side when we're given certain pieces. We can't, in these we can't use the Pythagorean theorem because we don't have two side lengths to use. All right, our last one right here, we have this angle right here, and we have the opposite, and we have the adjacent. So TOA, or tangent, of 68 is going to be equal to the opposite, which is 6, over adjacent, which is x. Now this is interesting because if we multiply both sides by x, that would get rid of this fraction. So we have x, to cancel this out, and then we have x. So we have x tangent times tangent of 68 equals 6. Now to get rid of the x by itself, now we have to divide by tangent of 68. So now we have to do the x is equal to 6 divided by the tangent of 68. So let's see if that's going to work here. 6 divided by, I'm going to use parentheses to make sure this works. 68 tangent, close parentheses, and I got 2.4. I round it, and that does look accurate for this one as well. Alright, so that is using sine, cosine, and tangent, or SOHCAHTOA. Now this one says the ramp on the back of a moving van is 3 feet high and rises at an angle of 25 degrees. How long is the ramp? So again, this would be the same idea, just drawing a picture for it. If you have the ramp on the back of a truck, let's just make this our triangle. And it rises at an angle of 25 degrees, so this is 25 degrees. And it's 3 feet high. We're trying to find how long the ramp is. I'm just assuming it is this spot. So we would just be using sine, cosine, or tangent to find that one. For the sake of time, I'm going to move on. Um, right here we have finding measures of angles. Alright, so let's take a look at this. To find the measure of angles, you need to use inverse sine, cosine, or tangent. So if I look at this calculator, your calculator might be a little bit different. But I have to click this inverse sign up here, and if I see this, it says inverse sine of something. So let's say we have 15. I don't know if we can do that. I'm going to clear it. 15, and I'm going to take the inverse sine of it. Okay, that doesn't work either. It's going to end up having to be a smaller number. So we'll do it when we get to 1. But find the measures of an angle. So usually you have two sides, and we're going to find the measure of an angle. So what is the measure of the angle in the triangle at the right? So we have the hypotenuse of 24. We're trying to find angle A. We have also a smaller side of 12, which would be the adjacent side. Since you know the length of the side adjacent and the length of the hypotenuse, we're going to use cosine, because would be cosine is adjacent over hypotenuse. So we're going to write and solve this. Cosine of A is equal to 12 over 24, or 1 over 2, or 0.5. And to get the A by itself, because we know the cosine of A is equal to 0.5, but we want to know what A is. We have to use the inverse operation, which in this case is the inverse cosine. So A, measuring angle A would just be equal to the inverse cosine of 0.5, and we plug that in, you get 60. So let's double check on here. So let's clear this, 0.5 inverse cosine is equal to 60. So this angle measure there was 60. You can use that to find the other angle measures as well. So why don't you try that? Pause it and try that. It says in the right triangle, the side opposite angle A. So we're going to make our right triangle. Let's just say this is A, B, C. In a right triangle, the side opposite angle A is 8 millimeters long. So that's going to be 8. The hypotenuse is 12, and we're trying to find the measure of angle A. So we have opposite and we have hypotenuse. So use the sine ratio. Why don't you pause it, try it, and then I'll show you the work in a second. Alright, so using that ratio, I found sine of A is equal to 8 over 12. Took the inverse sine of each side to get the A by itself, and then the inverse sine of 8 over 12 is 48.8. And so that would be the measure of angle A. So we'll say measure of angle A. That's too many humps for the M. Measure of angle A is equal to 48.8 degrees. Now, real quickly before we finish this up, there are things such as the angle of elevation, angle of depression. Those are terms that are used in more applicable situations. So the angle of elevation is an angle from a horizontal line up to a line of sight. An angle of depression would be an angle from a horizontal line going down. So if you look at a picture, if you're looking right here, this would be our horizontal line. Angle of elevation would be looking up. So this would make our angle of elevation. If you were up here in the blue, this is the horizontal line going straight away from you. You'd be looking downward. That would be an angle of depression for you. And using those, our understanding of that, you can look for creating right triangles. So in this case, like we're trying to find the x here. We know we have an angle of elevation of 20 degrees, and we know the height of that is 150. We can create a trig ratio to find that missing x. And here's how you do it. We'd have opposite and adjacent, so we'd be using tangent, would be of 20 degrees equals 150 over x. Multiply both sides by x, and then divide by tangent of 20, and you get 412 feet. So x would be 412, or about 410 feet. All right? So that's a real applicable problem using trig ratios and those things that are called um, angles of elevation or depression. All right? But that brings us back to our goal to use sine, cosine, and tangent ratios to determine um, side lengths and angle measures in right triangles. So we did both of those things there. So, ka, to, wa, so, ka, to, wa, so, ka, to, wa, so, ka.